So just a little bit of review from our special order for graphing. When you have a sine or a cos graph with all of those transformations, A is a vertical stretch or compression, B is a horizontal stretch or compression, C moves it left or right, and D would move it up or down. That's how you would do it if you followed normal transformation rules. But with sine and cos graphs, by noticing some of the patterns we saw before, we can do it as a shortcut. And this shortcut, I call it dab C, because those are the order that you're going to do things. So it's not from left to right anymore, because we're starting with our D value. Now our D values are sinusoidal axes. So if we start with our sinusoidal axes, in this case where we had 1/2 sine 2x minus pi over 4 minus 3, minus 3 would be your sinusoidal axis. That's your D value. And you would start by drawing a dotted line right at y equals -3. That's going to be the middle of your sinusoidal graph. Next, you're going to use your A value, your amplitude, to find the maximum and the minimum. Now remember, your amplitude is the distance from the sinusoidal axis, from the average, to the maximum and to the minimum. So in this case, if our amplitude is 1/2, we're going to start at -3, we're going to go up 1/2, and we're going to go down 1/2 from -3. And we're going to label those on our y-axis. So we've got them labeled here. If I go up 1/2, I'll be at -2.5. If I go down 1/2, I'll be at -3.5. Your B value always helps you find your period. And we had our period formula. I'll write it up here again. That we could find our period because it's always 2 pi over the B value. So we use our B value to find our period, and then once we have our period, we can divide that into 4 equal sections. Because when we graph sine and cos normally from 0 to 2 pi, we graphed in 4 equal sections to represent each of those 4 quadrants. And so now we'll do the same thing, but once we calculate our B value, in this case, our period, our B value is 2, so our period is going to be 2 pi over 2, which will just be pi. Mark pi somewhere along your x-axis, and then divide that into 4 equal sections. So here's pi, I cut it in half, I get pi over 2, cut that in half again, get pi over 4, and then I've got 1, 2, 3 pi over 4 as the last thing I would label. Now when I call it dab C, you do the dab all together, and we're going to do the C last. But once you're done D, A, and B, you're going to graph your sinusoidal graph without any of the shifts. So we've done that here in a dotted line in green. A sine graph, where does it normally start? A sine graph normally starts in the middle on your sinusoidal axis going up. So you'll start in the middle, and you've divided it into 4 equal sections, so then you'll go up to a maximum, back down to a minimum, back down to the middle, then down to a minimum, and then back to the middle again. Yes?
Will a sine graph ever not start in the middle? Or start in the
No,
middle?
a sine graph will always start in the middle. Now, once you move things left or right, it might look different, but if we call this our starting point, that is always starting in the middle. A cos graph always starts at a maximum. Okay, but a cos graph, it was a negative cos graph, then it would start at a minimum. A negative sine graph would still start in the middle, but go down first rather than up first. So now we've graphed one period of this graph with a dotted line because we haven't done the C value. The C value is when you're going to move left or right. You're going to translate that dotted graph that you've made either left or right. In this case, minus pi over 4 means move pi over 4 to the right. So we go back to our graph. Our starting point here, now if you move pi over 4 to the right, can you see that it would go there? This first maximum, if you move pi over 4 to the right, it would go there. And this one's a nice transformation because we've already got our x-axis separated into sections that are pi over 4. So it's easy to move things over. Sometimes you'll get a question like this and it'll ask you to move pi over 6 to the right. Then you'll have to do a little bit of figuring, well, where would pi over 6 be in relation to these other fractions? So now if I draw it, and I'm going to draw it with a solid line because this is my final graph, this is what it would look like moved pi over 4 to the right. You could draw arrowheads on the end to say that it keeps going like this. So as far as this is a sine graph, if we would look at where it would be, it's not starting in the middle right at x equals 0 anymore. But considering that this is still our starting point, because it's been moved pi over 4 to the right, it is still starting in the middle. So again, we start with our center line, use our amplitude to find our maximum and our minimum, use our b value to find the period and divide our x-axis into 4 equal sections. After you've done that, graph it with a dotted line before you translate it. So you get an idea of what your graph looks like, because then you can take these 5 points and move them left or right easily to get your final graph.